Yeah, so we were talking about vectors last time, and we saw that vectors are physical quantities which have magnitude and direction. Okay. Yes, we also discussed a little bit about trigonometry. So now today we will start by learning how to represent vectors. So vector representation and notation. So first of all, the notation used for a vector is an arrow. So whenever we use a symbol with an arrow on top of it, this symbol is read as vector E. Okay. So for example, this is used to represent a force F, which is a vector quantity. V is used to represent velocity as a vector quantity, whereas this would be speed, which is a scalar quantity. S would be used to represent displacement as a scalar quantity, and so on and so forth. Sorry, as a vector quantity. And displacement would become a vector because we are representing it with an arrow. Okay. So any symbol with an arrow on top of it is used to represent a vector quantity. The moment we put an arrow on top of the symbol, it means that that symbol represents a vector quantity. So just make a note of this quickly first. Yes, Harsh, we discussed about some basic trigonometry also last time. The definition of sine theta, cos theta, and tan theta. And that will come in useful again today as we are discussing more about vectors. Yes, Dhaneshwar, I will discuss about that also, the answer to the question. Okay. So this is the symbol, or what we can call as the notation used for vectors. Yeah, so I will come to the question and the discussion. Okay, so hope you are clear about this now, the symbol and the notation used for vectors. Now, next thing in this we'll understand is that sometimes you will also see a symbol like this, a vector quantity between two bars. So this becomes what we call magnitude of a vector. So for example, we say F is equal to 20 newtons. So this would represent that a force F is of magnitude. Magnitude, as we discussed last time, is the amount. Newtons. So as you can see, this statement here is just giving us information about the magnitude of the vector. It is not giving us information about the direction. Now, next thing is representation of a vector. Geometrically. How do we use a geometrical way of representing a vector? So the method is that we use an arrow. We draw an arrow to represent a vector. So vectors are represented by arrows such that the length of the arrow represents the magnitude of the vector. Whereas the direction in which the arrow head is pointing, so an arrow always has a head, is pointing along a particular direction. So that represents the direction along which the vector acts. So the direction in which the arrow's head points, that represents the direction of the vector. So this part is called the tail of the vector. And this is called the head of the vector. So wherever the arrow head is pointing, that particular direction becomes the direction along which the vector is acting. Okay, so this is how we represent a vector geometrically. Okay, so for example, you want to do something like now, like this now. Let's suppose we are given that our x-axis points towards the east, okay, and our y-axis points towards the north. And this is an arrow which represents E, where E is suppose a displacement of 12 meters towards east. Now what we want to do next is draw vector arrows to represent the following. B, which is a displacement of 8 kilometers towards north, and C, which is a displacement of 16 kilometers at 30 degrees south of west. We want to represent this. So let's just work out how we can draw these arrows that represent these particular displacements. Just try this out. I'll put up the answer on the board in just a moment. So just try to work them out in your notebook or paper or whatever first. Then I'll put up the solution on the board. Yes, A is representing a displacement of 12 meters towards east. Okay, so the arrow that I've already drawn, that blue colored arrow of A, it represents this quantity. So accordingly, how will you represent the other quantities, B vector and C vector, using the same kind of notation or the same kind of representation, which is vector arrows? Yes, that's correct. RF. So see, if we represented A with a vector like this, now this was supposed to represent 12 meters. You can see that roughly I'm using a scale such that this length is representing 12 meters. So now comparatively B has to point towards the north and it has to represent 8 kilometers. So B should be something like this. It doesn't matter whether I've drawn B over here or here or here. Anywhere I draw it, it's fine. But B would be, so the length of the vector B, roughly speaking, I don't want to make something very exact also. But if this length is some L, this arrow's length is L, this should be 2/3 of L. Okay. So you can see that since the magnitude of B is 8 meters and the magnitude of A is 12 meters, the lengths of their arrows are in same proportion. Two is to. This is 2/3 of the same length. Okay. But B is pointing northwards, pointing towards north. This is pointing towards east. Oh, kilometer, my mistake. Sorry. Kilometers would be huge. You would not be able to plot that. Sorry, just thanks for pointing that out. Let's keep them 8 meters and 16 meters. Here I would draw them like that. In comparison, how will I draw the vector C? 30 degrees south of west. Yes, very good. That's what we have to do. So if this is our west direction and this is our southern direction, this is pointing south, this is pointing west. So now the third vector that we are trying to draw, that would be somewhere here. This would be the vector, such that its length is supposed to be proportional to 16 meters, but its angle is, so this is the vector C, which is a displacement of 16 meters at 30 degrees south of west. In comparison to, for example, our original vector E, moving towards the east and like this. So you might ask now, what is the purpose of representing vectors with arrows like this? And that will become clear very soon as we learn to do some vector operations. Yes, speed is a scalar quantity, so we represent it with the symbol just v, Janeshwar. Whereas velocity is a vector quantity, so we represent it with v with the arrow. Yes, so that's also correct. So that's what you're saying is correct, Yuvraj. That we can also say that this is 60 degrees west of south. In the horizontal plane, 30 degrees south of west is the same thing as 60 degrees west of south. So we can also represent it that way. So the two statements are one and the same thing. Whether I say all right, people. So this is how we represent vectors. So let us now see some simple operations. Now, suppose vector A is drawn exactly like this. Now, draw vectors B and C if B is equal to 0.5 times vector and C is equal to minus 2 times vector. Let's understand what this means. So, B is equal to 0.5 times vector E means magnitude of B will be 0.5 times magnitude of B. And direction of B is same as the direction of B. That is what the meaning of this is. So use this now to draw the vector B. Yeah, I'll come to C also, and what you're saying, Aparna, is correct about C. Whereas C is equal to minus 2 times C. It means that the magnitude of C will be 2 times the magnitude of B. Magnitude can't become negative, but direction of C will be opposite. because there's a minus sign. So minus sign shows you that the direction is opposite. Whereas B is multiplied with a positive factor. For B, you're multiplying A with a positive factor, so its direction remains the same. Okay, so using this now, construct these two vectors. Yeah, so suppose vector A's length is not specified to me, so I'm just making a sort of estimated diagonal. Just estimate. So here it will become something like this. That I had drawn the vector E. In my diagram, I had drawn it exactly like this. It was the diagonal of a 3 by 3 wala box. Okay. So this was the vector E. So the vector B, which is equal to exactly half of this, will become like this. Should be parallel to this. Exactly. This should be the vector. Or I can show that same vector here also. And that same vector here also. I can show it anywhere, it doesn't matter. But as long as it is the arrow with the same length and the same orientation. So basically what I'm trying to say is that iska length agar L hai, iska length kitna ho jana chahiye? It should be L by 2. So that will show that B has a magnitude of half of it, and B's direction is along the direction. So B will become 0.5 times. Okay. And now in comparison, how will vector C look? Vector C will have to be opposite and double in magnitude. So vector C, you have to understand, it have to become something like this. C will have to be something like this. So magnitude of C is twice of magnitude of B, but direction is opposite in comparison. So C is opposite and magnitude of C is twice of magnitude of B. That is showing me that the vector C can be represented by the minus 2 times vector. So see, already intuitively we've learned our first vector operation, that what is the relationship between vectors when they are related like this, that E is equal to some number into B. Okay. If this number is positive, then they are parallel vectors. If N is positive, that means they are parallel. If N is negative, then they are anti-parallel or opposite. You learn this. Whereas magnitude of E will become whatever the magnitude of that number is into mod of it. In case it's a negative number, we will have to take mod of that. Okay, so let me take you through the whole question again. Then we'll understand everything in detail. So what was happening in the question was this. This was what was happening in the question. Given the vector E, so given vector E in the diagram, now we have to draw vectors B and C. If this is the relationship here, that B is 0.5 times 0, whereas C is minus 2 times 0. So मैंने hint क्या दिया था, अगर B 0.5 है, that means magnitude of B क्या हो गया? Magnitude of B is equal to half of magnitude. But because 0.5 is a positive number, the direction of B is the same as direction of B. So now coming back down here, you can see This is how we'll draw the vector. If this was the vector A, if this was the vector A pointing in this sort of direction. If you think again, suppose this is the north and this is the east. This is a sort of northeast direction, 45 degrees north of east. So B का भी direction क्या होना चाहिए? Same होना चाहिए. But B का magnitude half होना चाहिए. So whatever arrow I'm using to represent A, the arrow used to represent B should be half of that in length. Okay, so I've drawn two arrows. Now we don't have to exactly use a scale and draw exactly. It's just for the purpose of diagram. So roughly you can see that this arrow is half in length of this, but it's pointing in the same direction. So magnitude of B is becoming half of magnitude of B because this length is half of this, but the direction is same. So that means it's satisfying the condition that B is 0.5. Now similarly, what was given about the vector C, that C should be minus 2 times B. So uske liye hint kya tha, that C is minus 2A means that magnitude of the vector C is double of the magnitude of A, but the direction of C will be opposite to the direction of A. The direction of C should become opposite. This is the meaning of this statement. C is equal to minus 2A का मतलब ये है कि direction of C opposite हो जाएगा, but magnitude कितना हो जाएगा? Double हो जाएगा. So that is why we have now drawn C like this. We have drawn C to be a vector which, if you compare to the vector A vector और A vector कैसे है? Opposite direction. This vector A was going like this, so C is going exactly opposite. But its length is double. So C is opposite to A in direction and twice in magnitude. We can say that the vector C is minus 2. So from that now we have learned this basic operation, that if we say one vector is some number into another vector, then the magnitude of that vector becomes that number's mod times that vector's mod. Whereas if that number is positive, then the two vectors are parallel. If that number is negative, like in the case of A and C, then the two vectors are anti-parallel. Okay. So hope this concept is clear now. Mommy, which part you are not able to understand? Which part you wanted to see? Yes, Mommy, the question is clear. Okay. Now we come to the next concept related to vectors, which will help us solve quantities related to vectors, and that is components of a vector. This is with respect to a two-dimensional XY coordinate axis. Okay, so if this is our x-axis and this is our y-axis, and a vector arrow which we are using to represent a particular vector is looking like this. It says that this angle is theta. Okay. Then, very important, if we drop a perpendicular from this onto the x-axis, and if we drop a perpendicular from this onto the y-axis, then this particular length here is called the x component of the vector, and this particular length here, it is called the y component of the vector. In this diagram, the quantity Ax is called the x component of the vector, or you can say it is the component of vector E along the x-axis. And similarly, EY is called the y component of vector E. And you can see that Because of Pythagoras theorem, magnitude of the vector E is nothing but root of ax square plus E1 square. Okay. So just make a note of this first. So because this is with respect to the rectangular coordinate system, this is sometimes also called rectangular components. What we call as the xy components, they can also be called rectangular components. The vector. Okay, now next let us understand the relationship of components with the angle theta. So relationship of the components Ax and Ay and theta. So this is where our trigonometry comes in. What we learned last time, that will become important. So if my vector is such that theta is the angle it is making with respect to the x-axis. So suppose magnitude of the vector is given by the symbol capital D, which is the short symbol for magnitude, and theta is the angle of vector E with respect to the x-axis. Then when you drop this perpendicular here onto the x-axis and draw this component, you'll be able to see that this is a right angle triangle and this one is a right angle triangle for which cos theta is base upon hypotenuse. Okay, so base is how much? It is nothing but the x component, and hypotenuse is how much? The magnitude of the vector. So invert this relation now. So the x component becomes how much? The magnitude into cos theta. So this is the relation between the x component of a vector and its magnitude and angle. And like this, we get a relation for the y component also. But first, more to know. So the relationship between the components and the angle. This is the first relation. The x component is given by a cos theta. Where what is a? It is the magnitude of the vector, and what is theta? It is the angle with respect to the x-axis. Yes, so theta and component are interconnected. So for example, किसी भी vector का x component किस पे depend करता है? It depends on theta and the magnitude. It depends on these two things. Similarly, with the y component also, it depends on theta and the magnitude. Cos theta is the trigonometric ratio in a triangle, in a right angle triangle. If this is the perpendicular, this is the base, and this is the hypotenuse, and this angle is theta, we define cos theta as the ratio of base upon hypotenuse. We define sin theta as the ratio of perpendicular upon hypotenuse, and we define tan theta as the ratio of perpendicular to base. These are the three basic trigonometric ratios. Okay, so last time I had given you trigonometric ratios for three important type of triangles: 60-degree triangle, okay, 30-degree triangle, and 90-degree triangle. Okay, so writing this down, people. Yes, it is related to trigonometry. And in my last lecture, I had just given you some definitions about trigonometric ratios also. So it's just using that. So you don't have to do any other textbook or anything. You can just understand it from my last lecture's notes. Now, similarly, if we draw a perpendicular here, this becomes A1. So this AY, it is the same as this. In this triangle, the perpendicular is also AY. You can see this, the Y component is the same as the perpendicular in this triangle. It's exactly the same. So now, similarly, you can see that sine theta is defined as perpendicular and hypotenuse is ratio. So the perpendicular here is the Y component and the hypotenuse is the magnitude of the vector. So accordingly, the Y component of the vector becomes E sine theta. So that is our second relation. Vyom, you have not got the. Yeah, Daneshwar, I'll give you the answer to that. Vyom, you have not got the physics modules. Okay, I will see that you receive them. The physics module PDFs should have been sent to all of you through the WhatsApp groups. But in case anybody has not received, you can WhatsApp me and I will help you out with that. Yeah, Daneshwar, I will give the answer to that question. But first, note down these 2 points. Comic module is for 2 things. One is there is theory notes in it which you can read for your own knowledge. And second is there are questions in the exercise which you can practice again for your own benefit. Yes, Yuvraj, you will get the answer to that question yourself. By the end of today's lecture, you will get the answer to that question yourself. Okay. So anyway, are all of you clear with equation 1 and equation 2? The relationship of the x and y component with the angle theta. Okay, good. Now let's come back to the discussion about basic trigonometry that we were doing last time. So quick review of trigonometric ratios. Understand this? Okay. So first of all, we saw that any right angle triangle, if we are referencing this particular angle, then one of the perpendicular sides opposite to it, it is called the perpendicular. The side lying to its adjacent is called the base, and the third side is called the hypotenuse. So by definition, sine theta is perpendicular upon hypotenuse cos theta is base upon hypotenuse and tan theta is perpendicular upon base. Okay, so these are the definition of the three trigonometric forces. Okay. So this is there in my last lecture notes. I don't know, some of you might not have. No, so when we are writing this way, then see theta. It's not a question of मैंने इसको theta लिया है या इसको theta लिया है. It's a question कि suppose I'm talking about this angle. So which is P? P is the one which is opposite to this. Which is the base? It is this side. And which is the hypotenuse? It is the third side. It's like that. Okay? Then the common triangles that we saw, or the common angles. Now one of them, for example, was the 30-degree triangle. Okay. Now the question that I asked you last time, that why is sine 30 equal to cos 60 and vice versa? Okay. That you will understand just now. We saw that if we take this angle as 30 degrees, then the ratio of this side is to this side is half the ratio of the base to hypotenuse is root 3 by 2, and the ratio of 1 by root 2. Okay. Now I'll just give you an example. So the important thing to understand is कि यहाँ पे देखो ये angle 60. Okay. So here you just think about it carefully. If I first draw a triangle, where this side is some x, this side is some y, and this side is some z, and this angle is 30 degrees. Okay, so I know that x upon z will be equal to half, which is sine 30. Okay. Y upon z will be equal to root 3 by 2, which is cos 30. Now just invert this triangle. Okay, so this triangle was triangle ABC like this. Just invert this triangle and now place it like this. Same triangle, but I'm placing it upside down. Okay. So A is now over here, B is over here, and C is over here. So this angle is 30 degrees, but now this angle is 60 degrees. So AB is this side, it's X. BC is this side, it's Y. Okay, so it's the same triangle. It's exactly the same triangle, but I placed it this way. Okay. So now you can see that X upon Z can now be expressed as cos of 60. Okay. And from here, it is equal to half from equation 1. That's why sine of 30 is the same thing as cos of 7. And similarly, y by z is now sine 60, but that is equal to, from this equation, it is root 3 by 2 from equation 2. And similarly, x by y was equal to 1 by root 3 or tan 30. So here, y by x will be equal to tan 60, which will be equal to root 3 from equation 2. Because if x by y was 1 by root 3, so now you can see how the relationship between these words. So this shows why sine 30 is equal to cos 60. cos 30 equal to sin 60 and tan 50 is equal to 1 upon tan 60. Yes, basically because we have inverted it. Alright. So this is the proof of this. So this is what I was hoping people would work out last time. Yes, you have to note all this. This is part of your class notes. So it's your job to write down class notes. Oh, very good. Yeah, Bhavik, the notes are basically the guidelines of what we are learning in class. So for example, in the module, you will see that after we finish kinematics and the basics of vectors, the next chapter is laws of motion, Newton's laws of motion. So that is the same order in which we will be going. And you can work out questions from the exercise once we cover a given chapter. So now, for example, we are mostly done with kinematics. So you can, especially we are done with motion along a straight line, which is there in the module. A lot of practice questions are there in the exercise. So you can do those questions. And as you're doing those questions, if you have any doubts, you can keep sending to me over WhatsApp. I'll help you out. Arav, that is the value of sine 30 and cos 30. Okay. Those are factual things that if you draw a triangle which is right angle triangle with this angle as 30 degrees, then the ratio of perpendicular upon hypotenuse or the ratio of perpendicular upon base or all these things, they work out to these values. That is the trigonometric property of a 30-degree angle right angle triangle. Yeah, Manishka, you can just drop me a message. I will help you with the notes of the previous section. Module 1 mein beta. Bhavik, all these chapters are in module 1. Module 2 has different chapters. It has electricity and all this. Yeah, Hetvi, so I didn't get root 3 by 2. It is a factual matter. These values, sine 30, cos 30 and tan 30, these are mathematical facts. They are trigonometric values. So some values that, some common trigonometric values that you should remember are these. So I'm just listing out again the common set of values. Then sine 45 is 1 by root 2. Cos 45 is 1 by root 2. And tan 45 is 1. And similarly, sine 60 is root 3 by 2. These values we just saw. Cos 60 is half. And tan 60 is. So this is corresponding to this kind of triangle. This is corresponding to isosceles right angle. this side is x, this side is also x. This is the root 2x. But here what happens is that if this side is x, this side becomes 2x, and this side becomes x. And similarly, you have inverted that triangle over here for the 60-degree one. So this is x. For the 60-degree triangle, so that's why we have x. So you should just, for the moment, you should just remember these three sets of values. Theta equal to 30 degrees के लिए ratios, you should just memorize these. Theta equal to 45, क्योंकि memorize करने की जरूरत भी नहीं है because this is isosceles right angle triangle, so very easy. And theta equal to 60. Again, which you don't have to separately memorize because it has a relationship with 30. Yes, at least you have to learn these ones. Because these are going to be used very often in both physics and maths. So now based on this, let us come back to vectors. So in vectors, we saw that if we have a particular vector, which is making some kind of an angle theta with respect to our x-axis. Then the x component is given by the formula a cos theta, and the y component is given by the formula a sin theta, where capital A is nothing but magnitude of the vector, and theta is the angle with respect to x-axis. So find the x and y components for the given vectors. Let's do this as our next problem. Oh, so now we have this set of vectors which is given to us. Vector E is of magnitude, let us say 20 units, and this angle is 60 degrees. Then vector B let's say of magnitude 18 units, and this angle is 30 degrees. And vector C, let's say like this, and its magnitude is 15 units. You have to find the x and y components of all these. The three vectors which are drawn for you, you have to find the x and y components of. Okay. So quickly work this out. You've written down the formula for x and y component before, so use that formula. So use this formula above to work out this question. Okay, so people, hope you have worked out on these values. Bhumik, just concentrate on the question right now and note down that part later. I've given you enough time better to note down. So you can see that for the vector E, the magnitude of the vector is 20 units and the angle with respect to the x-axis is 60 degrees. So x component will become E cos theta. So that will become 20 into cos 60. Now if you look at your table, cos 60 is half. So it will become 10. So Ax is 10 and Ay is E sin theta. So that will become 20 into sin 60. So that will become 20 into root 3 by 2. Or that will become 10 root. So these are the components for the vector E. Ax is 10 and Ay is 10. Okay. Similarly, for the vector B, the magnitude of the vector is 18 units and the angle with respect to the x-axis is 30 degrees. So B's x component is this, so 18 cos 30. So 18 into root 3 by 2. So B's x component is 9 root. And similarly, B's y component is 9. And similarly, for the vector C, you don't have to do any calculation. You can see that for the vector C, it's along the y-axis. So x component is 0 and y component is only the magnitude, which is okay, people, this is clear. Good. So you have mostly all got this correct. Yes, Dhaneshwar, you got it correct. Adinath, correct. No, Adinath, अच्छा कोई बात नहीं, just got it right, doesn't matter. Okay, Bhumik, so hope this is correct. Okay. You understood this? Yeah. Bhumik, I don't know, you are asking me for this diagram or which diagram? Good, Arav. Okay. Okay, so done, Bhumik. All right. So now let us see how we can make use of theta is the angle, na beta. Theta is the angle with respect to the x-axis. Okay. Now let's see another example of how we can make use of this concept. Okay. Now a body makes a displacement of 1 kilometer towards east. So that is a displacement S1, and then 3√2 kilometers towards northeast. That is 45 degrees north of east. Okay, so this is S2. So take XY plane as the horizontal plane such that x-axis points eastward and y-axis points northwards. And draw vectors S1 and S2 as the vector arrows. Secondly, express the components of S1 and S2. And third, find the magnitude of the body's net displacement. That is S1 plus S2. It's the net displacement, the magnitude. So now if you just follow the instructions of the question step by step, you'll understand how our whole approach of vectors. That first of all, we learned how to represent vectors as arrow, and then Arav, just a minute. So just a minute, people. We'll come back to this question. There's a question about the previous question. There's a doubt about the previous question. Now in the previous question, the vector C. अभी देखो C के components हम कैसे निकालेंगे? So see, the vector C is lying along the y-axis. So if you draw the vector C here, it is like this. It's directly along the y-axis. So its x component is how much? It's 0. Now vector C से अगर मैं x पे perpendicular drop करूँगा, so how much it is? What is the component is cutting? It's 0. Whereas its component along the y-axis is directly how much? Its magnitude, 15 units. That's why C's x component is 0 and y component is 15. Is it clear, Arav? Yes, Arav, have you understood? Okay, good. So now let's come back to the question below. Now in this question, you will understand that how by developing the geometrical approach to vectors, we can now answer a question like this very easily. That, just a moment. Yeah. So just follow the instructions carefully. And by the time you come to this first part, actually, you will understand how to do the second and third. Okay. Just follow the instructions of the question carefully. Just imagine this, the body makes a first displacement S1, which is described as 1 kilometer towards east. No problem, Ara. Doubts can be asked at any point of time. It's not a matter of disturbing at all. It's no problem at all. Yeah, so coming back to this question. So S1 is the first displacement, which is 1 kilometer towards east. And S2 is the second displacement, which is made immediately afterwards, which is 3√2 kilometers towards northeast. So now using a standard XY coordinate frame, according to how you are instructed over here, that x-axis is towards the east and y-axis is northwards. You have to first draw these two vectors, and by the time you draw the two vectors, you will understand how to do second and third part yourself. Just try this out, people. Yes, Aparna, that is correct. Very good. Similarly, tell me for, yeah, that is correct. Good. So Aparna, you got the first and second part correct. Now just try to use what we have done in the second part to understand third part. So rest of all, people, tell me what is the magnitudes, sorry, what are the components of S1 and S2? Okay. So first of all, let us fix our coordinate frame. So that is like this. This is suppose our coordinate frame. The y-axis is pointing northwards and x-axis is pointing eastwards. So now in this, how will S1 look like? S1 will look like a displacement of 1 unit, 1 kilometer towards east. So S1 will look like this. Whereas in comparison, how will S2 look like? S2 will look quite a bit longer. But more importantly, it will be along a line which is 45 degrees northeast, okay, and it should be 3√2 kilometers. Okay. So now you can see that as far as components are concerned, for the vector S1, the x component will become 1 kilometer and the y component will be 0. Whereas for the vector S2, the magnitude is 3√2 kilometers, but the angle with the x-axis is 45 degrees. And you know that cos 45 is equal to sine 45 is equal to 1 by root 2. So S2's x component will be S2's magnitude into cos 45, that will be 3, and S2's y component will be S2's sine 45, so that will be 3 kilometers. So S2's components are this and S1's components are this. Yes, Aparna, that's correct. Very good. This This is the first part of the question, and this is the second part of the question. Found the components. Okay. So now let us work out what is the meaning of the third part of the question. So in the third part of the question, we are saying that we have to find the magnitude of the net displacement which is S1 plus S2. Okay. So let us say suppose that the body starts from some point P. Okay. Then makes a displacement of S1 to the point D. Okay. And then makes a displacement of S2 to the point C. So therefore the net displacement will be what? It will be A to C. Okay. Yeah, I'll scroll up. Okay. So understand this statement which I've written over here, and through that you will get the idea of how to solve the previous one. Okay. So now let us convert this statement into a diagram. Yeah, Bombing, have you finished with this? Oh. So now let us convert this statement that I'm saying over here into a diagram. Just read through this statement. Okay. And let's convert this to a diagram. So we'll understand here that in my equivalent diagram, what will happen is, let us say he started from this point E, and he made a displacement of S1, which was 1 kilometer along our x-axis, and he reached this point D. So अभी यहाँ पे पहुँच गया B. But then B से उसने क्या किया? He's made a displacement of no, Dhaneshwar, the answer is not correct actually. B say he's made a displacement of S2, which is like this, something like this. He's made the displacement S2, which is 3√2 kilometers like this, and he's reached this point C. Okay. Now in that displacement, okay, what is this component? So if I continue this line, and if I drop a perpendicular here, so ये कितना है? ये S2 का Y component है जो कि 3 किलोमीटर था, और ये कितना है? ये S2 का X component है जो कि 3. Okay. Now in this diagram, see what is his net displacement. His net displacement is the displacement vector from the initial point A to the final point C. So this is what his net displacement is. This line here is his net displacement. this is the net displacement, which is S1 plus S2. Okay. So we can see that net displacement, उसका magnitude कितना हो रहा है? It is the hypotenuse of this whole larger triangle. So this larger triangle has a base of how much? It has a base of 3 plus 1, 4. And a perpendicular how much? 3. So it is 4 square plus 3 square. So that is 5 kilometers. So that is what is showing us. Therefore, the net displacement, which is S1 plus S2, which is from the point A to the point C, has a magnitude of 5 kilometers. Okay. So forget about other things and try to understand this diagram for me. Just think like you would think in coordinate geometry. Na? ये point A से क्या कर रहा है? He is going along the east by 1 kilometer. Then what is happening? From that point B, he is going towards northeast by 3√2 kilometers. So he reaches this point C. So by definition, what is the final displacement? The final displacement is the displacement vector from where he started, which is the point A, to where he ended up, which is the point C. So it's this one. तो मुझे क्या करना है? ये वाले ट्रायंगल में ये वाला साइड निकालना है, S नेट. ये साइड निकालने के लिए ये पूरा बेस कितना हो गया? It is 1 plus 3. This entire base is how much? This part is 1, and then this part is how much? Is 3, because the x component of S2 was 3, and the y component of S2 was 3. So now going from A to C, you see along the base you're going how much? 4, and along the perpendicular you're going how much? 3. So the hypotenuse that you're covering, which is the net displacement, that is how much? It is root of base square plus perpendicular square. Have you understood it now? Okay, good. So basically you can see in this diagram that A to B is S1, which is 1 kilometers east. Okay. B to C is S2, which is 3√2 kilometers northeast. Okay. But A to C, यही तो मुझे निकालना है ना, and this is nothing but the net displacement. Okay, so Dhaneshwar, you are going from this point to this point like this, and then from this point to this point like this. ठीक है? तो मेरा net displacement क्या होगा? मेरा net displacement ये होगा, ये मुझे निकालना है. बट मुझे पता है कि ये कितना है, ये 1 है, और ये कितना है, ये भी मुझे पता है कि ये कितना है, ये 3 है, और ये 3 है. सो अब मैं निकाल सकता हूँ हाइपोटेन्यूज कितना है. So is it clear now, Dhaneshwar? Oh, good. So see, what is the use of the vector approach? Okay, good. Okay, so hope this is clear to everybody. Any doubt, please send me a message. Send me a text message, I'll help you out. Okay. Yeah, so Harshul, I'll explain once again. So see, what is happening is from some point E, I'm first making a displacement of 1 kilometers towards east and reaching this point B. Okay. And then from point B, what I'm doing is I'm making a displacement of S2, which is that 3 root 2 kilometers, like this, and reaching my final point C. Okay. So this is my displacement S1, and this is my displacement S2. Now, what is my net displacement? It is S1 plus S2, where S1 is basically A to B, S2 is basically B to C, and my net displacement is basically how much? It is A to C. तो ये डायग्राम में मेरा नेट डिस्प्लेसमेंट कितना है? मेरा नेट डिस्प्लेसमेंट है ये वाला वेक्टर, ये है मेरा नेट डिस्प्लेसमेंट S1 प्लस S2. अब मुझे जो है S1 के बारे में इंफॉर्मेशन है. I know that S1 according to my system, where I've taken this as my x-axis and this as my y-axis. According to this system, I know that S1 has x component equal to 1 and y component equal to 0, which I can see over here. Okay. So that's why this is 1 kilometer. Okay. And I know that S2, similarly, I know that S2, which is B to C, has an x component of 3 and a y component also of 3. So that's why I know that if I take the component of S2 along the x-axis, this is how much? This is 3 kilometers. And this is how much? Along the y-axis, this is also 3 kilometers. Okay. So now I have to just calculate this hypotenuse. So S net mera kya hai? It is just the length AC. So that is what? It is, if I name this point as D or something, this point here, it is square root of ED square plus DC square. So I'm just using Pythagoras theorem. So ED मेरा कितना हो जाएगा ये डायग्राम में? ED will become 1 plus 3 and DC is directly 3. So it is becoming how much? Square root of 4 square plus 3 square. That is 5 kilometers. So that is AC. Okay. So that is nothing but the magnitude of net displacement. Okay. Which is what I wanted to calculate. Okay, Harshul, so this is clear, I hope. So that is where this, yeah, good. So that is where this information became very important. ये components कितने थे ये यहाँ पे, that's right. Okay. Okay, so now we will see. Okay, one final thing. Okay, before we are ready to apply all this in kinematics in 2 dimensions, that kind of situation. Okay, Bhaumik, done. finished, beta, Mohammed? Okay. Now let us do an example like this, which is actually like a more practical example. So a particle at the origin O at time t equal to 0 on a horizontal floor, which is basically our xy axis or our xy plane, starts moving with a uniform velocity v, such that or you can say velocity v of components Vx equal to 16 meters per second and Vy equal to 12 meters per second. So find the magnitude of his velocity. Second, the coordinates x comma y after 5 seconds. And third, the magnitude of displacement, the displacement's magnitude at t equal to 5 seconds. So this is like the reverse type of question. In the previous question, I had given you the angle and the magnitude of the vector, and you have to find the components. इसमें उल्टा है, इसमें आपको components दिए हुए हैं. X and Y component of velocity is given, and from that you have to find the magnitude of the velocity, and you have to find the coordinates of the particle X and Y after 5 seconds, and you have to find the displacement vector's magnitude after 5 seconds. So a particle which is sitting at the origin at t equal to 0. Yes, very correct. Okay. And what will be the unit of the magnitude? Velocity का magnitude का unit क्या हो जाएगा? Same as the components unit, which is in meters per second. Yes, Dhaneshwar, we have done discussion about the 3 equations of motion along a straight line with uniform acceleration. However, we'll be using those equations in the future also. Don't worry. Okay, right now we have just done a preliminary run of one-dimensional motion. Yes, that's correct. Yes, Harshul, that is correct. Very good. Yes, Adinath, correct. Very good. First part is correct. Correct, Aparna, correct. Mohammed, correct for the second part. Yes, Adinath, correct. Okay, so see the first part. Yes, correct. So magnitude of the velocity will become square root of vx square plus y square. Okay, like we discussed earlier, the magnitude of any vector is square root of x component square plus y component square, because the vector itself and the x component and y component they form a right angle triangle. ये वाला वैल्यू इसका x component है और ये उसका y component है. So because of that, we have this relationship. So like that over here. So this is the relationship. So this is square root of 16 square plus 12 square. So you can take 4 common. 4 square plus 3 square. So that is 25. 4 into 5. So 20 meters per second. That becomes the magnitude of the velocity. So this is the first part's answer. Now we will see that just as in one-dimensional motion, for the second part, we'd see in 1D motion, we had seen that V was delta x by delta t, or this was V into delta t. Okay. This is 1D motion along x-axis. So now we will see with uniform velocity. V is uniform. Now like that we'll see in two-dimensional motion in the xy plane. If the acceleration is 0, so that is uniform velocity. V. So what that means is that x component of velocity is constant, and that is equal to delta x by delta t. And not only that, but y component of velocity is also constant. So that is equal to delta y by delta. Okay. So in other words, what that means is that the x component of displacement becomes x component of velocity into time, and y component of displacement becomes y component of velocity into time. Okay. So what this shows you, these two equations here, okay, what they ultimately mean is that the x component of displacement, or delta x, which is the change in x coordinate, okay, that becomes equal to Vx into delta t. That is nothing but the x component of velocity into the time interval. Okay. And similarly, the y component of displacement, delta y, or that is the change in y coordinate. That delta y is equal to Vy into delta t. So Vy is nothing but y component of velocity, and delta t is nothing but time interval. नहीं तो ये बेटा horizontal axis है ज्ञानेश्वर. This is not under motion under gravity. I told you that xy plane is a horizontal floor, so we are not taking gravity into account. वो बाद में आएगा projectile motion. Okay, so therefore we are seeing that in this case Vx was 12 meters per second. Therefore in time of 5 seconds delta x will become how much? 12 into 5. Oh, sorry, Vx was 16, right? Was Vx 12 or 16? 16, sorry, my mistake. So Vx was 16. So this will become 80. Okay, so Vx was 16 meters per second. So 80 meters. This will be my change in x coordinate. Okay. Similarly, Vy was 12 meters per second. Therefore, in 5 seconds, delta y will become Vy delta t, or it will become 60 meters. So now I know that at t equal to 0, the coordinates were 0, 0. Therefore, at t equal to 5 seconds, the coordinates have become, let's say, x prime and y prime. So x prime will become 0 plus delta x, so 80 meters, and y prime will become initial coordinate plus delta y, that will become 60 meters. So the coordinates of the particle, the position, will become like this. So at t equal to 5 seconds, go to 80, 60 meters. And this will become the position. Okay, so I'll just minimize this so you can understand the whole thing in detail. And then we'll also understand it from a diagram point of view. Okay. So this is what we used to apply in 1D motion. Is what we know. We used to apply in motion along a straight line. Now we extend this now to motion in a two-dimensional plane, a 2D plane. Okay, so two-dimensional. Yeah, Bhamit, I'll scroll down, don't worry. Just giving a chance for everybody to go through this whole thing. Good. So now you'll see that as far as the displacement is concerned, you're going from 0, 0 to the point 80, 60. So the magnitude of the displacement is just square root of 80 square plus 60 square by distance formula. Is the distance of the straight line joining the origin with that point. So that is becoming how much? Now another way you can approach the displacement is because your velocity is constant. So displacement is also velocity into time. So magnitude of displacement can also be expressed as magnitude of velocity multiplied by time. Okay. So you can see that third part, we wanted to find out magnitude of displacement. So there are two approaches. Okay. One is that you're going from 0, 0 at time t equal to 0 to the point 80, 60 meters at t equal to 5 seconds. So the magnitude of the displacement is nothing but by distance formula. It is this. That's one way. Or you can also use the relation that since velocity v is uniform, okay, therefore displacement is equal to velocity into time. Okay. So the moment I say displacement is equal to velocity into time, it means that magnitude of displacement is equal to magnitude of velocity into time. So the magnitude of displacement will become magnitude of velocity, which was 20 meters per second, multiplied by the time, which is 5 seconds. So it is 100 meters. So that's another way to understand why this is the case. The magnitude of displacement will become 100 meters. So this is the complete understanding of this. Okay, so just note this last part down. Just continue. Okay, people, so understood this particular example. So you'll also realize that geometrically what's happening here is that because your velocity is uniform, actually your particle is moving along a straight line. But only difference is that straight line is not along the x-axis or along the y-axis. It is now with at some angle with the x and y-axis. तो क्या हो रहा है, मेरा particle origin से start कर रहा है at t equal to 0 with a velocity vector which is like this, let's say. So that velocity vector is such that it has an x component of 16 and a y component of 12 meters per second. So in fact, it will be inclined in this way. ऐसा होगा because x component is more. Let me just redraw this whole thing. It will be something like this, the velocity vector. So this is where it starts from at t equal to 0, from the origin. And what happens is because its velocity vector is uniform, it ends up going along a straight line. And it ends up somewhere here, let's say, at t equal to 5 seconds, where this is t comma 60. And that's why the magnitude of the displacement becomes 100 meters. Because the magnitude of the velocity was 20 meters per second. So this is actually also motion along a straight line, but the only difference is our x and y axis are different. Okay. So this was okay. Yeah, Harshul, some doubt you had in the previous part? Okay. Okay, Vyum, I will get it sent. The physics module will be sent to your group. Don't worry. Okay. So now let's end up with one final example. Now in our next example, a particle is again at the origin at t equal to 0 of the xy plane, okay, and has a velocity u such that the x component of u is 0, but the y component of u is 5 meters per second, okay, and has uniform acceleration e such that the x component of acceleration is 1 meter per second square and the y component of acceleration is 0. So find the magnitude of velocity at t equal to 2 seconds and the coordinates x comma y at t equal to 2 seconds. So just try this out now. So the diagram is not for this question. The diagram was for the previous one. Yeah, so now work on this question, Mommy. Next. Yeah, then you will get the recording of the lecture in any case. You get the video recording and the whiteboard notes. Getting it in every session. Yeah, I will get the module sent to your WhatsApp group. Okay. So let's understand in this question how we will solve it. So what is happening is, see, we will divide the motion itself into two components. Along the x-axis, what is happening is initial velocity is 0, but acceleration is 1 meters per second square, uniform acceleration. So therefore, Vx will be ux plus ax into t, basically making use of this relation, this kind of thing. So velocity as a function of time will become t, because a is 1, okay, substitute ax is 1, and displacement will be, in this case, delta x, it will be uxt plus half axt square, because here we are making use of this relation. But only its displacement along the x-axis. So I'll replace s with what? Delta x. I'll replace u with what? Ux. So delta x as a function of time will become 1 by 2 t square. Okay. So therefore, at t equal to 2 seconds, the velocity's x component will become 2 meters per second, and the displacement's x component will become 2 meters. Okay. That is just the x component. Now similarly, we'll solve for the y component also. But y component के लिए क्या हो रहा है? उल्टा हो रहा है. The velocity is uniform and the acceleration is 0. Okay. Similarly, what is happening along the y-axis is that your velocity was 5 meters per second and your acceleration was 0. So therefore, delta y will be equal to Vy into delta t. So y as a function of time will become 5t, and Vy will remain constant. Therefore, at t equal to 5 seconds, 2 seconds, Vy is constant at 5 meters per second, but y coordinate is becoming 10 meters. So here the x coordinate will become 2 meters. Okay. So the velocity will have a magnitude of square root of vx square plus vy square. So substitute these. So root 29 meters per second. Square root of 29 meters per second. That will become the velocity. And the coordinates will become 2, 10 meters. Okay. So this is the complete solution of this. Okay, people. So this is where we'll pick up from in our next lecture, okay, which is basically we have started motion in 2 dimensions using the components of vectors, component of velocity vector, component of acceleration vector, etc. So please do a very thorough revision of today's lecture, because we have covered a lot of things like how to use trigonometric ratios to find components and how to find the magnitude of a vector from its components and things like that. And finally, how we made use of which one, Dhaneshwar, you are having a doubt in? Half at squared, na? So acceleration was of magnitude 1. Okay, so that's how we got half of 1 into 2 square at 2 seconds became 2 meters. Okay, that's how we got the displacement. Okay, so that's it for today's lecture, people. I will send you the video recording and the whiteboard notes. Okay, so just go through that once, revise carefully, and you can do some questions from the module for kinematics also for your own practice. Motion along a straight line, relative motion, etc. We've discussed earlier. All right. So that's it. Thank you, people.